Hello, everyone. My name is Tim Chou, and this is one of 5 different talks about key technologies I think will change things in the future for companies, for industries, for countries. In this talk, we're going to focus on the Internet of Things. It's an area I became interested in maybe about 5 years ago. I ended up writing a book called Precision. Solutions, principles, practices, and solutions for the Internet of Things. So what I want to do today with you is really kind of talk about why this might be interesting, a way to think about the technologies and the challenges, and then conclude with 2 big things. One is, what is the implication of the Internet of Things to people that make things, make machines, and what's the implication to people who use these machines? You may be aware of this, but this is actually a few years ago, the World Economic Forum wrote a report talking about the Internet of Things. And they started out by saying, during the past 15 years, the Internet revolution has redefined B2C, business to consumer industries, such as media, retail, and financial services. This is really where I would say most of tech has been used is in these industries. You know, how you bank, how you pay for things, how you buy stuff, and how do you watch things. But what they made the point of is they believe that in the next 10 years, the Internet of Things will dramatically alter the other industries. What are those other industries? Energy, manufacturing, transportation, agriculture, healthcare, right? All these areas, right? Which together account for 2/3 of the global GDP. So this is the vast amount of the global spend, the global infrastructure is really not media and financial services. It's all the rest of the fundamental infrastructure that feeds us, clothes us, put power into your buildings, clears the water, cleans the water, et cetera. When we talk about the Internet of Things, like, what does that mean? What is the Internet of Things? I'm going to start by saying that most of the work in technology we have done up until now has all focused on what I'm going to call the Internet of People, meaning applications and technology that serve us, right? People, humans, right? Whether that means buying stuff or, forecasting my sales or whatever. I believe at the end of the day, the computers are talking to people. This is something my Stanford students get to learn in their class when I do this lecture. I go, well, here's a big revelation. Things aren't people. People aren't things. So what do I mean by that, right? Well, let's start with number one. There are way more things in the world than people. So it's estimated, in fact, if you listen to a John Chambers speech, that there are 600 billion things in the world, right? Whether that's a blood analyzer or a tractor or a compressor, 600 billion things. Now, that's literally 100 times the number of humans that there are. So there are way more things than people. Number two, things have a lot more to say than people do. The most we can do is we can, click a little, type a little, well, we can talk a little, I guess. But modern day wind turbines have over 3,000 sensors on them. So they have way more to say than people do. And let me just make the third point. Things can talk much more frequently. So in the mining industry, there is a machine called a longwall shearer. This is in the coal mining industry. It basically cuts a swath through a coal seam. It's a very large, almost football field, American football field sized machine that basically carves out, a kilometer underground, a seam of coal, transports it onto a conveyor belt, ships it up top. Now, one of the challenges as this machine runs is it creates what's termed an artificial roof, meaning as it digs through, it's got rock above it. Well, every once in a while, this rock collapses onto the machine. Well, when that happens, they got to go dig out their multi-million-dollar machine, and they lose productivity during that period of time. So what are they doing? They've installed sensors on the top of this roof, which operate at 10,000 hertz, 10,000 cycles per second. So that is way faster than any of us could ever type or move a mouse, et cetera. So there are going to be way more things. Things have way more to say. Things can say it much more frequently. So that's why I make a point to people. Well, why would you think that technology we built for the Internet of People would work for the Internet of Things? So that's what I want to talk about is really, let's talk a little about what those things are, just to give you a sense of that. Talk about how those things are connected, how you collect data from those things. What could you learn from those machines? And finally, what would you do differently? Just to make a point of it, in the world of the Internet of People, we actually had to build applications that did something like allow you to buy a book or, to book an airline reservation before we could gather enough data to be able to learn from it. So what did we do here? No, actually, we can learn from it before we figure out what to do. So let's start with things. One of the, I think, things that maybe most people have not thought about is the fact that things, and I talked about sensors, are getting much more smart, much more sensor enabled, largely because of what's happened in cell phone technologies. Accelerometers, which are pretty fancy pieces of sensor technology, which determine whether or not you're moving quickly. Those things right now, because they're buried inside every cell phone, they cost about $1 a piece, right? So modern day cell phones have over 12 different kinds of sensors on them. You're seeing in this slide some examples of that. There's actually, just to make a point of it, a cell phone in Japan, which actually has a radiometer on it, because you can gather why you might in certain areas want to know whether or not there's any radiation. So sensor technology has gotten dramatically cheaper across the board here and is now starting to make you realize that at some point in time, I like to use the phrase, you could imagine a cell phone inside every one of these machines, meaning these machines get smarter and smarter. And in fact, we'll talk a little about this, if you look inside modern day automobiles, there are 6 to 7 different computers inside them. So as these things get smarter and smarter, we are going to want to take the step of connecting to them. In another lecture, we talk a little bit about the 5G technologies. But by the way, there are many different ways that people are going to end up connecting things. Just to give you a sense of this type of technologies or the type of technologies, there's actually a company in England which builds a patch that they use to, when you come into the emergency room, to get your blood pressure, respiration, et cetera. And what they want to be able to do with it is to be able to predict, right? Are you like, should you go, to the top of the list in terms of making sure that you're seen? So they started working on the patch, they developed the patch. One of the questions was, are we going to connect this with Wi-Fi technology? Well, it turns out that if you're going to use Wi-Fi, the amount of power required, so that's one of the parameters here, is going to be so much that I need to put battery packs associated with this patch. Well, as soon as they did that, you'd have to recharge the batteries, be able to, wash the battery casing, et cetera. So they decided to go to, in essence, a Zigbee, you may have heard this word, type of mesh network, which is much lower cost and allowed them to use disposable batteries. So my only point of this is there are going to be a large spectrum of technologies that can be used or will be used depending on how much power is required, depending on how far away I am, and depending on what data rates I'm going to require. Okay, Let's assume we connect those. What's the next big step? Well, we can start to collect data from those machines. We can collect everything from actual, what the error codes are, what the laser power level is, all the way to the actual echocardiogram that's generated by the ultrasound. But I think one of the things that's very interesting here is what's starting to happen relative to how I collect this data. So I was talking to one of the largest oil companies in the world. The latest oil drilling rigs off the Gulf of Mexico have 30,000 sensors on those oil drilling rigs. So I was looking at those guys going, wow, it's incredible. Like, what are you doing with the data? Where are you collecting it, et cetera? And they looked at me and they said, well, most of this data is digital exhaust. Digital exhaust. I love the expression because what they're saying is they're not doing anything with it. It's just going into the air. And why? Because if you look at, right, conventional, traditional technologies for collecting data of the order of magnitude we're talking about here, the cost of doing this is prohibitive, right? So that is obviously, and we talk about this in another conversation, one of the huge advantages of the world of cloud computing. But collecting the data is a huge issue for a lot of people in terms of trying to use traditional technologies. But I think there's something even more important happening, which is, let's assume I convince my boss that we're going to spend millions of dollars collecting this data. Well, the next big question is going to be, hey, Tim, what are you going to do with this data? And I think here, we're going to have to think about this very differently than how we came at this in the old world of business intelligence, et cetera. Huge amounts of time series data or large imaging data sets are not amenable to the old, we'll call it business intelligence approaches. Instead, I think what we're going to start to see is the usage of the technologies. And we're going to do an entire section on artificial intelligence, but the artificial intelligence and particularly neural network technologies, which hold enormous promise for being able to learn from these type of data sets. And I'm going to make this point in the section on artificial intelligence, but one of the things that we know at this stage, this is actually taken from a slide that was built by the head of Google Brain. And it basically says that, hey, we're able to get more accurate prediction the more compute we throw at it and the more data we throw at it. That neural network technologies, whether it's purely linear or just more linear, you're getting near linear improvements in performance if you throw more compute and more data. And by the way, we talked about how cloud computing is going to be able to give people access to more compute and more data at a lower cost. So finally, okay, I collect all that data, I throw a bunch of AI at it, et cetera. Well, what am I going to do differently, right? And here, as I said, I'm going to break this conversation into what am I going to do differently if I'm a maker of a machine, the maker of a combine harvester or a forklift or a wind turbine. And second, what am I going to do differently if I use these machines? I'm an airline, I'm a hospital, et cetera. So enterprises that build machines, well, at first step, you can improve the quality of service. This is a combine harvester. In the world of wheat farming, grain farming, one of the things that's true is there is a moment in time when the moisture level of the grain reaches the right point before the rains arrive that you want to harvest. And that window is not, all year long. It's like weeks, maybe a month-long period. Well, at that point in time, I don't want my multi-million-dollar harvester to be unavailable, to be down, that needs service, et cetera. So if I can start to use data from these machines to be able to improve the quality of the service of these machines, great, because that's going to make it better for me, the buyer of this AGCO, Gleaner, et cetera. I also can reduce the cost of service. So this is there in the United States, there's a company called United Rentals. They're one of the largest construction rental firms in the world. They rent construction equipment. Well, right now they spend about, actually probably spend more than this. They spend over $1 billion in maintenance of this equipment. And by and large, most maintenance today occurs the old-fashioned way, which is if you've owned automobiles, you know that they'll tell you, well, okay, every 6,000 miles, you should replace the oil. Well, it turns out if you happen to be able to drive in California in a beautiful weather, you probably could go 12,000 miles. And conversely, if you're taking this automobile down to Dakar or something and driving in a road rally, well, maybe it's 1,000 miles and you better. So again, with data and understanding of these machines, if I can make any material difference, which I would argue you can, to the cost of service in $1 billion spend on service, I can now take that profit and move it all the way to the bottom line. But I think something more important is going on. That's really great. Reduce cost of service, improve the quality of the machines. But the machine of the future, and this I like to say, is going to look like this. There's a bunch of sensors, a bunch of actuators, a big computer in the middle, and a lot of software. And if you want to go see one of these, just show up down at the Tesla dealership. That's exactly what that thing looks like. I actually did a talk about a year and a half ago to the over 50 CTOs of the Tata Corporation. If you're not familiar with them, they are the largest conglomerate in India. They own everything from steel mills to automobile companies. And I made this comment that that's the future of machines. Later on that day, the guy who's the CTO for Jaguar Land Rover, so they actually own Jaguar Land Rover, he got up and said, well, you know, Tim said that the future is a bunch of sensors, a bunch of actuators, big computer in the middle, a lot of software. He said, I only wish it were that way, right? The modern day Jaguar has 6, 7 different computer systems in it, and none of them talk to each other. So my comment to that group, and I have said this to guys that make machines, I go, look, if you want to see the future of what it might look like with machines, which are increasingly software defined, maybe you ought to understand a little bit about where we've come from in the world of software. And I'm going to suggest that there have been 3 fundamental business models. The first business model was we developed a product, we shipped it out there, and we weren't connected to it. So that was a PeopleSoft application or a Siebel application. And then we sold service, meaning access to information. This is the so-called maintenance and service revenue line. And that business model worked really, really, really well. Model 2 happened, in hardware many years ago, which is people said, well, shoot, if I can connect to that machine, I can provide more personal and more relevant services and have additional revenue. In fact, in my tenure at Oracle, we ended up doing this as, hugely profitable business. And then obviously Model 3, which we talk about in the cloud computing section, is really the model that we all see today, which is I deliver the product, whether it's CRM or an HR application, as a service. So I manage everything about it. I manage the performance, availability, and security of that, and I deliver it to you per seat or per transaction, et cetera. Okay, so that's the business models we've seen in the world of software. Let's now move to the world of machines. Well, this model, many people always wonder, well, why is GE interested in the Internet of Things? Well, it turns out, if you look at GE's business model, they sell you a jet engine or a locomotive or whatever, but most of their business is actually service revenue on that machine. And by the way, largely in the disconnected state. And that's pretty much a lot of machine manufacturers. That's the world that they live in. Model 2, we are starting to see. So this is actually an example of a locomotive company actually located in Australia, which has taken technology which allows them to connect to the locomotive, collect data from the locomotive, and provide guidance to the locomotive operator on when to speed up and slow down to save fuel cost. Actually, this is used by Norfolk Southern in the United States. And the reason I have this on here is you can gather that if you can start to tell the operator what to do, well, the next big step is, why don't you just do it for them? And so this is actually a automated train that's bringing iron ore from deep in Australia's outback into Perth, and totally automated, which you're starting to see in the world of transportation. So many of you have heard about the words, autonomous driving, et cetera. Well, let's now start thinking about it as if I built a car and I wanted to deliver it as a service, well, how would I go do that? What would my business model be? Well, my business model is pretty obvious. I deliver it by the ride. I'd say, hey, when you want a ride, I'll charge you for that ride. Well, as you all know, whether it's Lyft or Uber, et cetera, right, that business model is well in place. So what does autonomy have to do with this? Well, it turns out the most expensive thing in that ride is the driver. And if I can eliminate the driver out of the story, right, not only can I probably improve the safety of the drive, but I actually can reduce the cost dramatically to the point that, well, why do I ever need to buy a car again? So this is why the disruption in the automobile industry, whether that's occurring because of electrification or occurring because of autonomy, is huge, because its economic impact is huge. We're seeing, as I said, multiple business models already in operation here, whether that's in the traditional companies or in the new age companies. So the last section I want to talk about is, well, what about enterprises that use machines? Why do I care if they're connected and collect data? What difference does that make? Well, if I'm an airline, and I know they're in a world of hurt in the COVID era, but they've always had this big challenge, which is a large amount of their profitability is totally related to consumables costs. So their operating margins are heavily influenced by the cost of the consumable. What is that consumable? It's jet fuel, right? So if I can manage the consumption of jet fuel by even a little bit, by using knowledge about that particular plane, the route it's taking, the condition of the engines, et cetera, and I can reduce consumables costs, well, that improves my margin almost immediately. So if I'm an airline, I want to be able to operate more precisely for purposes of reducing a jet fuel cost. If I'm a utility, well, I can deliver higher quality service. There's actually Duke Energy is one of the largest energy companies in the United States. They actually use technology to be able to sense, by the way, 60 times a second, what the phase angle is in the power grid, and based on that, be able to predict whether or not there's going to be a blackout and reroute power, et cetera. So I can use technology of connecting these machines, these power generation machines, to deliver higher quality service. In the world of agriculture, well, hey, if I use less fertilizer and less water and less pesticides more precisely, well, that reduces my consumables. It's better for my cost structure. But oh, by the way, if I'm using, less pesticides, less herbicides, I'm actually improving the quality, I'm improving the health, I'm improving the sustainability of my farming by virtue of operating more precisely. And finally, just to make a point of it, this is in the world of transportation, I can operate more safely. I always ask people, what do you think the number one cause of failure of computer systems is? Well, it turns out it's not software, it's not hardware, it's none of that. It's us, it's humans. And if we can take the steps of automation, and which is occurring all over the place, we can take the human out of the loop. Not only, as I pointed out, you could reduce costs, but you can also improve the safety of these systems. So with that, hopefully you got a little bit of an understanding of what the Internet of Things is, why it matters to people who make machines, make things, and why it matters to people who use machines. I'll finish by telling you a small story. I actually published the book in Vietnam about 2 years ago. Uh, the prime minister, I wasn't there, was quoted as saying, "This book is a roadmap to the future of the Vietnamese economy." And I'll leave you to think about why that might be.